Good afternoon. Today we are going to see some questions. So I can say fill in the blanks, but are relates with MCQs. Again, I can mention. So we can form a number of MCQs from this. So go to basic so that you are in position to solve any MCQ. Shear force is defined as. So we know shear force. This is the unbalanced force. So we have unbalanced force, on left or right of section, on left or right of section. Now how we will have MCQ on this? Shear force is defined as A, unbalanced force on left of section, B, unbalanced force on right of section, C, both A and B, and D, none of these. So you may have question like this. Same we can have second bending moment. So we can have same unbalanced moment. Same question can be framed unbalanced moment on left or right of the section. Left or right of section. So it may have left side or it may have right side. Then at zero shear force, bending moment is. So we know at point of zero shear force, bending moment is maximum. Bending moment is maximum. Then we have the polynomial function of shear force between two concentrated load is. Now this is most important, and for this one we have to keep in mind these diagrams. Whenever we will go with the question, we can come these images in front of our eyes as soon as we have such questions. So we can have this, and if we will draw shear force diagram, then we have shear force diagram in this fashion. So polynomial function will be x to the power 0. So polynomial function of shear force between two concentrated load is 0. So is polynomial function is 0, it is horizontal line. Then we can have the polynomial function for bending moment diagram. So how we will get bending moment diagram? So we have this value 25, 25, 25 and 25. Now, if we will go for bending moment, then we can have bending moment. So this is x to the power 1. So this actually you may see this is parabola, but we can have like this. So x to the power 1. So we can have polynomial function for bending moment diagram is 1. Because our polynomial function increases, so here we do not have anything, here we have 0. Now it is 1. Then the polynomial function of shear force diagram in the span of UDL. Now, if we will consider a beam, and we have beam with UDL. So let us we have now this as 40 kilonewton per meter, and then let we have this as 4 meter. Then we can have 40 into 4, 160. So we will have 80 and 80. And if we will draw shear force diagram, then we have shear force diagram in this fashion. So now if we will write equation for shear force, then how we will get this equation? So this is 80, and then we have this as 40, and this is x. So what will be equation? 80 minus 40x. So shear force equal to. And then it is polynomial function is 1. So we have 1. Now, if we will go to the bending moment diagram, then we are going to get, if we will write the equation for bending moment, so we will get m is equal to 80 into x minus, then value we have that is 40 into x square by 2. So we have 40x square by 2. So what is polynomial function? 2. Maximum polynomial function, maximum polynomial power will be considered as polynomial function for that equation. So here we have 2, so it is 2. Then the polynomial function of shear force in UVL. Now how we will get UVL diagram? So we can have this, let us, we will have this will be increasing. So whatever value we will not go for these values, And now if we will draw shear force, so this is y, this is suppose x, then so this is value, let us we will consider that is 60, and then total span we have 6 meter, then we have this as y. So if we will find shear force at distance x, then how we will get it? So we will have like this. So this is reaction r, this is 60, so this is y, this is x, and then we will have shear force that is equal to r minus half into x into y. Now how we will find y? So by using similar triangle, y by x equal to 60 by 6, and we will get y is equal to 10x, and then your equation becomes r minus half x into 10x, and then it will be r minus 5x square. Then you can see polynomial function is 2. So for UVL, for shear force diagram, it is 2. So your value that is increasing by 1. So the polynomial function for bending moment in UVL. Now we have just made the equation. So I will go for that equation. So we can have this as r, then we have this as x. We got this value that is equal to 10x. So we have this as 10x. And then if we will find bending moment, then we have r into x. So m is equal to minus. Now we have this value 1 half base into height, and then this will be at a distance x by 3. Then what we will get? Minus 1 half x into 10x into x by 3, and from this we will get r into x minus 5x cube by 3. So what is maximum power in this equation? So 3, so we are going to get it as 3. So try to understand, try to frame the equations, then we can find polynomial function. The polynomial function in shear force diagram dash dash than that of loading diagram. So we can say greater than, greater than. Only in case of concentrated load, what will happen? So in case of concentrated load, just we have seen that when, so we have in this way. So we do not have any polynomial function here also and here also. So no polynomial function we have. Otherwise, your polynomial function in shear force diagram greater than that of loading diagram by 1, except between the concentrated load or concentrated load and reaction. Then the polynomial function in bending moment diagram, then that of loading diagram. Again, we have greater, and that greater by 2, I can say. Except again, we have concentrated load. Otherwise, if we will go to UDL, then what will happen in UDL? We have UDL in this fashion. So if we will draw shear force diagram for this, then we have shear force diagram for this is in this way. And bending moment diagram, you can say we have like this. So x to the power 2, x to the power 1. So it gets increasing. So in UVL also, if we will go in UVL also, then you have this will be x to the power 1. If we will go to shear force diagram, as load increases, our load is increasing. So our slope should increase. So this will be x to the power 2. And then if we will plot bending moment diagram, then you will get it as x to the power 3. So it increases, and that is by 2 compared with your loading and moment diagram. Then moment diagram and shear force diagram is again for moment, my polynomial function is greater than that of shear force diagram, and that is by 1, because it increases from loading to bending moment by 1, and it decreases from bending moment to loading. So it is increases by 1. Increases by 1. And if we will go downward, so downward to upward, then we can say decreases by 1. So how we will have this question, that you have to think, and then you have to solve this. So today we will stop here only. So these are some basic things which relates with your shear force and bending moment diagram. So thank you.